He currently is a professor in the Art Claire Trevor School of Arts. He has been a professor in robotics and computer science. He's been a practical teacher of sculpture and interactive technologies and installations. But these are the things I didn't know about. When he was young, he worked in iron foundries pushing hot metal. And then he was on a horse as a cowboy on a 58,000-acre ranch. This is in Australia. So he grew up in Australia, and he did those interesting things, trying to discover himself as an artist. So his next bit of work was he went to art school. He studied sculpture, and he got a few degrees in that. He did not get a PhD. Why would you in art like that? And then in the 80s, he worked as an artist in sculpture and interactive installations, and he caught the attention of some roboticists at CMU, who then invited him to come to CMU, look around for a year and a half or so, and then they said, well, we'll have to try to get you a faculty line, but it isn't easy without a PhD. So he got a professorship, a faculty slot in University of Florida, where he made a new program in electronic intermedia. CMU got their act together, offered him a faculty line, and hired him back as a professor of art and robotics. It was a special line at CMU. He was then appointed European Professor of Interactive Environments. Then, after several years, came to UCI to establish Arts Computation Engineering, ACE, a graduate program they had there. But he loved Europe, so he kept doing a gig in Europe for several years in Barcelona in one of their cognitive systems courses. He recently ran a great conference at UCI, very interdisciplinary, called A Body of Knowledge. And finally, after 10 to 15 years of promises, he completed a major work, this book of his. And today, I believe, he will say something that probably derives from the book. Thank you.
No, I don't need to. I've got this. Do I have this? Am I on? Yes. Hello. Thank you so much, David, for that lovely introduction. And it's a real pleasure to be here. And I know I'm speaking to a mixed audience. And I hope that what I have to say is both interesting and confusing for a while at least. Because it is a confusing subject. Embodiment, materiality and cognition, insights from skilled practice. John Ruskin, some of you may know of, said that skill was the unified force of experience, intellect and passion in their operation. And shortly afterwards, about 50 years later, the British philosopher Gilbert Ryle made this statement: overt intelligence performances are not clues to the workings of minds, they are those workings. So, this is what the talk's about, and I'm going to start by clarifying what I see as some of the problems. The practices of the arts, plastic and performing, are spatially, temporally, and culturally situated. They deal in direct sensorial engagement with the body. They engage with materiality, artifacts, tools, and with other people individually and in social groups. These practices are embodied, situated, and materially engaged. Now, I say this because this idea of intelligent practice in the world is in stark contradistinction to conventional conceptions of cognition, which are steeped in the mind-body dualism. So, conventional cognitivist conceptions of cognition are not well equipped to address intelligent action in the world, materially engaged skillful coping, socially interactive modalities of meaning-making. As a result, conventional cognitivist conceptions of cognition are not very useful for anyone who wants to understand the intelligences of making and doing in the world. And intelligent making and doing in the world is something that is epitomized by the practices of the arts in our culture. So, problem statement 2. The mind-body dualism informs the technical ideology underlying digital culture. The separation of matter and information and hardware and software map precisely onto the mind-body dualism. And the very existence of these digital technologies which populate your lives seems to validate mind-body dualist assumptions. Now, if we look back at the intellectual history of the West, we see that the mind-body dualism is absolutely fundamental to Western thought. Yet, there is no evidence for its existence. It is a belief, like any religious belief. So, what's the upshot of all this for design? Okay, here we are walking around thinking we have a mind and a body, thinking that there is matter and information. And these ideas may well be preventing us from understanding better or more accurately what we are in the world, thus making it difficult to invent or design technologies that work optimally for people walking around in the world. It's all very. It's the value system of the academy that we happen to be sitting in right now, right? Notice that, well, I'll get onto that. The value system of Western science and philosophy, since the Enlightenment at least, and if you want, you can trace it all the way back to Plato. But outside the ivory tower, and when we are outside the ivory tower, when we're playing volleyball or whatever we're doing, people conduct themselves in rich and complex modalities of intelligent action that are seldom articulated, seldom represented as symbols, that are tacit in the terminology of Paradigm. So, if that's the problem, what is the solution? What can we do about it? Well, we can be rigorous in our identification and examination and analysis of the axioms, the beliefs that underpin the disciplines and the philosophical systems that we subscribe to. That's no easy task. That is very, very difficult work. And it's one that's seldom endorsed by the academy, which is strapped into a straitjacket of disciplines, each with its own axiomatic assumptions, which they don't tell you about, they just assume that you believe. The second thing we can do is we can search for better paradigms to inform our work. Now, over the last 30 years, new approaches to cognition have emerged. And these provide insight into and leverage upon the nature of cognition in the world. And I'm very proud to say that some of that foundational work was done right here by my colleague David Kirsch, by Ed Hutchins, and other people. UCSD has led the development of post-cognitivist paradigms of cognition, amongst other places. So, I'm now going to say all of that in just a bit more detail. So this is a kind of premise for my position for research. If the arts are a class of human practices that have refined intelligent action in the world to a high degree, then practices in the arts provide a useful foil or perspective from which to examine some ideas fundamental to cognitive science. Cognitive explanations, conventional explanations of cognitive dimensions of arts practices and embodied practices in general fail, because internalist paradigms have minimal purchase on embodied, enactive, and materially engaged dimensions of cognition. What I mean is that if you believe in a theory of cognition which has everything to do with symbols in the mind being manipulated by algorithms which are presumed to be operating in the mind, then you can't say much about what my hands are doing in an intelligent or stupid way. Now, the culture of computer science entails a commitment to a dualistic ontology of matter and information. That dualism, hardware and software, is a reification of the Cartesian mind-body dualism. The Cartesian dualism is ontologically fundamental in Western thought, in the sciences and in the humanities. But there is no scientific validation for the Cartesian dualism, not a shred. It's just an idea that suited someone to put about in the 17th century for their own particular psychological needs. Right? So, does this mean that the fundamental philosophical premise of Western philosophy is simply nonsense? Probably. Now, if you'd like to know what I really think, yeah, I tend to be a little bit provocative, so you'll just have to get used to that. There are clearly shades of meaning and nuances in all of these things I'm saying, but I'm attempting to compress about 20 years' thought into 45 minutes, so forgive me if I skip some details. Okay, so cognitivism, that is that modality of thinking about cognition, which is also called computationalism or internalism, asserts three things. One, that information and matter are different and separable. Two, that thinking is computation. Three, that computation is platform independent. That's functionalism, was an idea that Hilary Putnam came up with and then rejected later. The idea was that intelligence can happen in transistors or in neurons. It doesn't matter because it's all the same process, right? And this is a premise of artificial intelligence, right? Or was. Now, I've used this term axiom. And what's interesting when you start to think about, look at disciplines and the way they premise their different positions, is at root they tend all to be grounded on shifting sands of beliefs. There are some fundamentals you simply can't prove, you just have to accept, whether you're talking about mathematics or physics or philosophy or whatever it happens to be. Right? There's a substrate of belief, which seems quite unscientific. The belief in the separation of matter and information is axiomatic in computer science. Interestingly, it's not axiomatic in other disciplines. Biologists don't talk about it that way. So, we believe that we have a mind and a body, and that they're somehow separate and different and somehow mixed together in some mystical way. We believe there's information-free matter, and we believe there is immaterial information. What empirical or scientific basis do we have for these beliefs? None at all. What would be the consequences of not believing them? It would be a reconfiguration of the value system of computer science. I'm not saying that the hardware would necessarily change, because the functional nature of the technology and how we explain it and what we believe about it are two different things, right? Now, this is where the rubber hits the road, or whatever analogy you'd like to use. I've been around interface design, interaction design, human-computer interaction for a long time. On the periphery, no doubt. I have I've built interactive systems, quite sophisticated systems for embodied interaction, and I see that the discipline of human-computer interaction and its related disciplines struggle to create fluent kinds of interfaces. And I think that one of the reasons for this is this deep commitment to the Cartesian dualism, which both describes the way we believe the technology to work and the way we believe humans to work. Now, there was a media studies guy by the name of Matthew Kirschenbaum. He said something quite funny. He said, if the devil is in the details, then media studies has been positively angelic, which is it was funny. It was a long time ago. I think they've got better. Now, what I want to say, just, bouncing off that amusing quote, is that the devil is in the details. But in this case, the devil is in the discursive details. The language we use, the way we construct this terminology, has an ideology riven into it. We talk about interface, peripherals, implementation details, input and output. These are not value-free terms. These are terms that become components of an ideology. Right? So this is a kind of philosophically reflexive and analytical engagement with the technology and the discourses of the technology that doesn't tend to happen very often in departments of computer science. And one of the people who drew attention to this was an extraordinary scholar by the name of Philip Agre, who was for a time on the faculty here at UCSD. And he called for what he called a critical technical practice. That is, a technical practice which had the ability to be reflexive about its own methods and its own beliefs. I think that was a very important argument to make, and sadly, it wasn't heeded as much as it might have been. But we're not just talking about a discourse which is contained within a closed community like plasma physics or steam turbine engineering or archaeological reconstruction. We're talking about a technology which has become socially ubiquitous, as water is to a fish. Right? You've got your devices on your laps right now. Jay Bolter called this our paradigmatic technology. This is the technology that we not only use, but it also provides metaphors for other things in our lives. What I'm going to suggest is that in that way, the digital devices on your pockets and in your laps are a kind of a Trojan horse that carry beliefs. Now, we hear this all the time. I've got a friend who talks about, some students having a very fast processor. We talk about our storage capacities and our bandwidth. I had a student once who said that some surprising experience crashed all her models, which was a very funny thing to say. But all of these kinds of terminologies demonstrate that we're taking computational metaphors to describe the behavior of our own minds, right? Are the analogies valid? And what happens to us when we accept those metaphors, not as metaphors, but as actual descriptions of our own processes? What opportunities do we preclude? So one of the interesting things about this is that historically and geographically, the development of cognitive science as a discipline and the development of artificial intelligence as a discipline happened in the same place, at the same time, amongst roughly the same people. So, cognitive science and artificial intelligence were certainly born joined at the hip, if not Janus-faced. Cognitive science says the brain is a computer. Artificial intelligence says intelligence is reasoning on symbols. Each paradigm justifies the other, so we can think that a computer is a brain and a brain is a computer. Putnam's functionalism writ large in social discourse. Now, this doesn't quite follow, in fact, but I'll say it anyway. One of the things that has happened with digital culture as this technology, which was developed for doing accountancy and making mathematical calculations, has expanded out over culture to perform all sorts of different functions, right? Is that we have come to believe that there's nothing strange about the idea that digital computation is applicable to all possible things that all people do anytime, right? That it's somehow as value neutral as water. There's just this commodity called computation, and you can apply it to everything in the same way that we breathe air or drink water. There may be a problem with this. One of the dimensions of this commitment to dualism is a privileging of the abstract over the concrete. Right? We love abstractions, we love equations, we love generalizations, we love things represented as symbols. Right? Wash out all the dirt. You know? So we as a culture tend to privilege things to the extent that they're dematerialized. And I think we've got to the point where this has become a problem culturally. Notice that explains why the technicians run the laboratories in the basement, and the more abstract the professors are, the higher up their offices are in the tower building, right? It explains why the technicians aren't paid very much and the professors are paid a lot. It makes a distinction between intelligence and skill. And my question is this a principled distinction? Is it a really meaningful separation of two different kinds of things, or is it a kind of value judgment that reinforces a social order? So we've got these parallel things happening. We've got the valorization of abstraction in the academy, and we've got the notion of immaterial information in computing technology, and they support each other because they both come from the same philosophical root. They're part of Western culture. Digital computing could only exist as a product of Enlightenment philosophy. So this is the way I see it. Scholarly and academic disciplines mine the world for information. They mine the world for symbols. It's a kind of extraction and purification process, right? They take materiality, and they produce symbols, text, equations, theories, and poems. And look at that. Alphanumeric symbols. That's what goes in and out. Right? The arts do something different. They take the world and they make more world. Right? They don't extract from the world a string of symbols. Now, we can discuss this in more detail because I know that we can make all sorts of interesting exceptions. But the argument is that, right? That a potter takes some clay and shapes the clay and makes a pot. The potter doesn't make an equation for a pot. And because of this distinction between skill and intelligence, there's a kind of hierarchy, especially in the academy. The people that take world and make world, they're not paid as much, and they don't have such nice offices as the people who mine the world for symbols. Now, the digital world is a world of representations. There's nothing else, right? But the map is not the territory. And I would say, in very general terms, that artists work in the territory. So clearly, we're all sorts of mixtures of all of this. And one might say that people are fascinating because they both exist in the world of ideas and the world of materiality. But don't you see that I'm then restating that same dualism? I'm saying there's a difference. And what I'd like to do is get to a point where we don't talk in terms of that difference. That's a tricky thing to do, as I've just demonstrated. How can we speak of intelligence without implying that it is external to materiality? That's the challenge for cognitive science, right? And that's the challenge for philosophy. So within that, there are two ideas. The idea that intelligence as a phenomenon exists separate from our biology, right? That it's not an organic component of what we are as living creatures. And secondly, that the activities of intelligence are separable from embodied behaviour. Right? We seem to believe both those things, but there's no evidence that that's correct. Certainly something to talk about. So, having laid that philosophical basis, I want to just talk about some immediate challenges of the time we are living in. So, humans, as we know, have developed all manner of technologies. And often those technologies are mapped to the body in really subtle and complex and rich ways, right? Musical instruments are a great example. The evolution of the violin is an exquisite example of the interaction between virtuosity and intellectual imagining and artisanal skill of the makers of the violins. And each of those three things drives the other over centuries to produce this extraordinary technology. But notice that there's nothing about a violin that makes it easy to use. The exact opposite. The very nature of a violin is that it forces you to develop capabilities in order to get out of it the potential that's there in the relationship between you as a skilled user and this as an artifact that affords highly sophisticated interaction. So the artifact itself, like so many artifacts in the pre-computational world, facilitate sophisticated skill development. What digital interface has ever done this? Every single, the motivation for every single piece of interface design is to make it simple, to make it easy, right? This could be a problem. Now, some of these ideas are just ridiculous, right? I've yet to see a touchscreen interface to a bicycle. It's just a ridiculous idea, right? Why? Because the bicycle is a technological artifact which is so perfectly adapted to the sensorimotor situation of the human body that it essentially hasn't changed for 150 years, right? But now we come back to this question of skill versus intelligence. Is playing violin a skill, or does it take intelligence? When you're riding your mountain bike down a steep hill and avoiding rocks and this and that, are you simply exercising skill, or are you doing something more? How do you distinguish? Or should we distinguish? So, we have seen, and if you look at the history of technology, social history of technologies, you see over and over again that, and I'm not being technologically determinist here, but you see that as new technologies are introduced, the way they influence human culture in both negative and positive ways takes time to manifest. Whether we're looking at the Industrial Revolution or the development of the telephone or radio or the printing press or whatever you like, as technologies develop and evolve, the shape of society as it wraps around them changes and certain kinds of strains occur, and society adapts in different ways by changing laws, right? Right now we're seeing a lot of stuff about privacy and democratic process and Facebook and social media and all the rest of it. This is a perfect example of how a new kind of communication technology has really upset social mechanisms, right? I believe that in the case of these technologies, psychological and developmental problems are also emerging. And I'm putting this under the general category of sensorimotor cognitive disability. Now, you may or may not be aware that myopia is being detected in younger and younger age groups. More and more children and adolescents are wearing glasses. Why is this suddenly happening? Right? Does it have something to do with the way we interact with this technology? Does it have something to do with extended hours of training the vision in a growing human being on a small rectangular illuminated screen just a few inches from the face? Right? It's entirely possible. Likewise, and I just give that as an example that's clear and known, right? But I think there are all sorts of more subtle ways in which our technologies and the interfaces reduce sensorimotor dexterity. So, intuitive interfaces are inherently de-skilling. That's what makes them intuitive. You don't have to learn them, you don't have to practice, you don't have to be precise. You know, our keyboard here, I can slam that keyboard or I can stroke that key, and it's always a B at the typeface and size that I already defined. I have a project which I would love to realise, which is a keyboard that is sensitive to finger pressure by producing letters of different type size. I think it would be really interesting to use that keyboard and to be able to manipulate the type size by finger pressure. That would be inducing some sensorimotor sophistication. It would be inducing some kind of learning or training, right, that would increase dexterity, increase sensitivity. So I only say that because clearly it points up the fact that most of the tools we use dumb us down, right? There's a very good chance that a lot of the technologies we use are making us stupid. So, where does intuition come from? I would say we learn through our bodies, through being in the world. This is pretty well established in developmental psychology, right? Once you've picked up a brick and dropped it on your foot, you have a pretty visceral sense of the mass of objects that are made of stuff like that and the kind of impact they can have on things fleshy or non-fleshy, right? This is the way we learn about the world. We fall downstairs. Right? Now, from just the proliferation and iteration of thousands and thousands of those experiences of increasing sophistication and subtlety, we develop expectations and predictions about the way the world is going to work. Right? Now, what happens when you have a kid who spends 6 hours a day playing video games in which there is a false physics? Do we learn wrong intuitions from applications with false physics? So I suspect that we do. Now, I'm going to get back to that point in a second, but first I'm going to talk a little bit about this problem of user-friendly applications, particularly in a pedagogical context. Okay, we know this, right? Apps compete for our attention. The better they grab our attention, the better they sell. Who would buy an app that was difficult or boring? No, we want it to be jumping around and really easy. And we want it to give us all kinds of rewards, illusory as they might be. Now, there's an entire industry, the most profitable industry in the country, if not the world, which is making lots and lots of money out of giving you things that are easy and fun. Right? That's capitalism. So the point is that dumbing it down makes money, so there's no incentive not to dumb it down, because then you wouldn't sell stuff and then you'd go broke. Right? But as collateral damage, something else is happening, right? We're being reduced in our ability to autonomously amuse ourselves, to play, right? You know how it is. You get on the bus, boom, out comes the phone. You know, I'm not even going to sit there and look around and see who's on the bus, right? Soon as there's a moment where my attention is not being grabbed, I go for the technology that will grab my attention. Well, that's interesting to observe and reflect on, because that simply didn't exist 20 years ago, or even 15. So there are changes going on, changes that we should be aware of. Okay, that's a bad pun. So here, what happens when that technology is ported into a pedagogical and educational environment like this one, right, is that the values that sell that technology are not compatible with the values of education, right? The problem is that anything that's worth doing is usually irreducibly difficult. That's why we have to learn it. Right? So there's a conflict between these tools that make things easy and the fact that getting good at stuff is inherently difficult. Now, I see that I'm running out of time, which is a shame because I'm only halfway through. Or I might be a quarter of the way through. I could say anything. You wouldn't know. But I'm going to move ahead. I wanted to tell you something funny. I'm building a 30-foot boat on UCI campus. It amuses me to do non-academic things on a university campus. And I'm doing it for a number of different reasons. And this is what it looks like, or this is what it looked like about 6 months ago. And this is what it looked like about a year ago. It was 2 rectangles of plywood, 30 feet long and 4 feet wide. And I set myself this little design task: how much of a boat-like thing could I build out of 2 rectangles? And there's a long conversation, I won't go into it, but in any case, you know, there was this process of bending these 2 big planes. And it's a boat structure that's symmetrical along 2 axes, so it has 4 quadrants, which are all should be essentially identical, right? And then the question came, how do we know? How do we know that this wooden thing that's sitting on a non-flat surface that has internal qualities that result in it not bending absolutely uniformly? How can we make sure that every quadrant is geometrically the same as every other quadrant? That's a very interesting challenge for thinking and doing intelligent things in the real world. And I work with students, and I work with engineering students and mechanical engineering students, and I confronted them with this problem. I said, okay, how do we know if that angle is the same as this angle? How do we know if this curve is the same as this curve? And they were dumbfounded. They were really dumbfounded. And the next thing they did is they went running to their computers and their phones. And this was literally happening. I go, what are you doing? How can you possibly get the answer out of that? What are you going to put in? Right? And it was like, oh, you know. It's like the joke about the Finnish people that run out of vodka. That's a different story. Any case, all they needed was this: a piece of string, a weight, a bubble level, these things. Ancient tools for achieving practical tasks like getting buildings to stand up. Right? You can do all that with incredibly simple technologies, and people have done that with incredibly simple technologies for millennia. They built Gothic cathedrals and Hindu temples, right? And they got it right, and they didn't have any software at all. They had no CAD programs, you know? So, that's a whole other issue. I'm going to rush on now because I do want to talk to you very briefly about these new paradigms of cognition and what they are and what they mean. So what are these new paradigms of embodied cognition? Okay, well, they go by different names, but some of them are called situated, inactive, embodied, distributed. Sometimes you hear embedded, sometimes you hear extended. These are all new paradigms of cognition that attempt to embrace the material, spatial, prosthetic and social dimensions of the worlds we live in. These are dimensions which essentially cognitive science has not considered because it was wedded to an idea that thinking was immaterial, that it's the operation of the manipulation of symbols in some abstract reasoning space, i.e. the skull or the computer, right? So I'm very happy to see that over the last 30 years there has been a flowering of these new ways of thinking about cognition which have asked very interesting questions, right? About how it is that we exist in the world, how it is that we operate in the world, not about abstract notions about reasoning or logic. So these paradigms attend to intelligent doing in the world. There's a bunch of history here. I'm going to skip some of it, but there are some very important people who have said very important things about it. Hubert Dreyfus was one of the first. There's a great book called What Computers Can't Do. Gilbert Ryle is a philosopher who predates this whole movement but said some very intelligent things. Andy Pickering, a sociologist of science, came up with a terminology which I have found very useful. Because he was talking about scientific experiment, and he coined these two phrases, the representational idiom and the performative idiom. Now, let me remind you that what I'm trying to do and what I'm trying to talk about here today, at least in part, is trying to get a cognitive explanation or a cognitive handle on what people are doing when they're acting intelligently in the world, and specifically how to understand what it is that artists are doing when they're acting intelligently in the world. And I think that these new paradigms provide a language, a set of ideas through which we can develop a new language to talk about cognition in arts practices and in embodied practices in general. And that is all sorts of other stuff here. I'm going to clip right through it because we're basically done. I published this book last year. It's the product of about 20 years' work, and it's about the things that I've been talking about and a lot of other things besides.